Hello, everyone. Welcome to HTAP Summit this year. Yeah, this is our year 2, and it's also a lovely day today, right? So I can see a lot of old friends here. You may join our last year, the HTAP Summit, and you are here today. So really appreciate that. And today I'm going to introduce a little bit, fundamental concept about distributed system, the scalability. So why scalability is so important, right? Today I think we are in the area of generative AI. I believe that everything will becoming bigger and bigger, especially the data. So that introduced some new requirements to database system, especially the requirement of the scalability, putting to the need of scalability to the next level. So as a CTO of a database company, I attended a lot of customer meeting talking about our technology. Interestingly, one of the most commonly asked question to me is all about scalability. For example, hey, what's your maximum data volume you can support? What's the maximum QPS or TPS of your system can reach? What's the, can your system's architecture to support unpredictable, workload? And this, or what's your biggest use case in production? Something like that. Some of you may even ask this question directly to me, right? So it is all about scalability. So, but when we talk about scalability, it is, not only about, data volume. It's not only about the scalability of the capacity, but also some, other things like read scalability, write scalability. Can your system, handle the unpredictable traffic or the read and write pressure from the online traffic? And of course, elasticity. Can your system automatically scale out to meet the traffic peak? And after the peak, can this system automatically scale in back to normal to reduce the cost without changing the application code, right? And also for a OLTP system like TiDB, people always have more requirements like with all of this scalability thing, can your system also handle the consistency and of course something like ACID transaction, more things like this. And all of these fancy features combining with the need of scalability, and it is not that easy to build, right? So let's wait a minute. Let's shift our focus to our neighbor, data warehouse. When I was preparing these slides, I suddenly noticed that we haven't talked about the scalability of modern data warehouse in recent years, right? Just like I'm not going to ask my friend Reno from Databricks, hey, can Databricks support hundreds of terabytes of data? I don't need to ask this question because hundreds of terabytes is like a no-brainer for the product of the Delta Lake or the Databricks. We just start it. You're all set. I don't need to ask this question. So that makes me thinking, what have changed? Just like this scalability issue of data warehouse is suddenly vanished. So what changed? Yeah, here is a blog post posted by Databricks. You can see the petabytes on the blog title. That means, wow, today the petabytes it become the unit of technical blog post. Yeah, it's amazing. And so that's the proof, right? The scalability is not a big issue to the data warehouse. So let's what changed? Yeah, let's bypass all the technical details and straight to the core of, this question. I think a concept, the idea of, separation, especially the separation of compute and storage, this great idea played an important role in the, new architecture of the cloud data warehouse. So with the help of this architecture, so the modern data warehouse can leverage the elastic computing resource provided by the cloud vendor. At the same time, they can also leverage the low-cost storage, something like the blob storage, the S3, also provided by the public cloud, and to provide a better user experience for their product. It is not only the improvement of the technology or from the product side, but this architecture also enable the modern data warehouse a new business model, like pay-as-you-go business model. That makes the cloud data warehouse a multi-billion US dollar market today. So let's back to the database world. Can we apply the similar approach to database to solve the scalability problem for the transactional database? Believe me, a lot of vendors, a lot of projects have tried this on this path by getting scalability by the separation of the different components from database. So in the next few slides, I will do the quick overview to brief introduce the history of the database by getting the scalability by the separation. Okay, the first try is some people think, hey, maybe I can just replace the local disk with remote storage. For example, running a database instance on top of EBS, the remote block storage. So this architecture actually have some, the good, get a limited scalability of the capacity. And another benefit of this architecture is people, from the user's perspective, finally we can pay separately for computing and storage. That's good, right? But the downside of this architecture is still obvious. Right? It's still a single process. All the database logic, like MySQL or Postgres, is still the single process running on a single node. Even though we replace the disk with a remote or cloud disk, but all the database logic, they are coupled in the single process. That means the read and write, we don't have the read and write scalability for the real world traffic. That means you have to always preserve the resource for your peak time. But for the transactional database, OLTP database, my own experience is about 80% of the time the database is idle, but only like 20% of time is in the peak time. But this kind of shared everything architecture, that means you need to always prepare for your peak time. That means paying extra money for your database. Okay, but it is. I'm not saying it's not good, because a lot of RDS service on the cloud using this architecture is quite good. A lot of people are using that. And let's fast forward to one of my favorite product. It is a revolutionary product in my mind, which is Aurora. I think it's the first milestone of the idea of compute and the storage separation architecture applied in database world. The first milestone. I like it. And especially, it have a great idea from their paper, which is log is the database. That means they separate the log out from the database kernel that can have a better, scalability. And even though the Aurora is not open source project, but we still can learn a lot from its architecture from their paper. So the basic idea is that they create the advanced shared storage system and decouple the storage and compute. And the shared storage layer can actually support multiple reader on different nodes, different physical nodes. That means you can actually launch multiple read-only instance in different nodes. That means your read can spread the read pressure to multiple nodes. You can have scalability on the read. But the downside, currently, Aurora only supports a single writer. So that means all the write traffic will still go through one single node. That means there will be a bottleneck when you have a massive write pressure. So that's good. But I would say Aurora is a great product. Many users are using it today, and is very successful. And stage 3, another kind of database using a totally different approach because they want to get almost unlimited scalability on both read and write and also capacity. So this kind of new database, new SQL database, choose a totally different approach. A great example is Google Spanner, our product TiDB, and the Cockroach, Yugabytes. This kind of new SQL database learned a lot from NoSQL movement. So I'll do a really quick summary of this architecture. So first, using TiDB as an example. So first we separated storage and compute from the architecture point of view. We make computing layer totally stateless, which is the SQL layer is stateless. And we further separate the storage layer into multiple small logical chunks, and putting the small shard into different nodes so that every node can support both read and write workload. And of course, by splitting the data into smaller chunks, that means we can have the scalability on the capacity too. So from the computing layer, you can see every node can serve both read and write traffic. That means we don't have a bottleneck here. So let's see. The database using this architecture, we can achieve the scalability on the storage, the capacity, the scalability of read, scalability of write. It seems like the scalability problem of the database have been solved by this architecture, right? I think that's true. Here's a great example of one of our amazing customers, Flipkart. Flipkart is the #1 e-commerce website in India. So they have a great post a couple months ago, share their experience scaling TiDB to 1 million QPS. I think that's a great example that proves this kind of architecture can support massive scalability. So that seems the problem is solved, right? So here comes a small summary of what we have today, right? The RDS, Aurora, and the TiDB for different levels of scalability and also the features. But don't take me wrong here. I'm not saying one product or one architecture is better than another. You always choose the right database for your application. Every product in this different category is really good. Yeah, a lot of people using different technologies. So, but I would say, TiDB actually doing a great job in the scenarios with massive scale. This is some quotes from our real world customer. The people like you and me, normal people, can, actually get benefits from, the scalability of database. Like, for example, the scalability in real world means, the more responsive query on, your trip booking website, or more comprehensive order history on your online order history, right? Or maybe the less waiting time on the traffic peak traffic time. So all of this, like these good feedbacks from our customer using TiDB to build their amazing product. So appreciate that. But we don't stop here, because people always need more. People never get satisfied, especially for the engineer. We need the better performance, lower cost, and the speed of scaling, and also the better maintainability. And I would say the optimization and the innovation on the technology part is just it's an endless journey. So we didn't stop here, and we ask ourselves what we can do more, right? So remember, I just mentioned the modern cloud data warehouse using the idea of separation, and with the help of the blob storage, so that they can get nearly unlimited scalability, that story, right? So can we apply the similar approach to TiDB? Yes, we already did that. We make one step further. So last year, we started a bold trial on our database kernel. We applied the idea of, applied this idea to our latest product, the TiDB serverless on the cloud. So our focus is on separating our storage layer into a tiered storage layer. Yeah, it's a little bit like data warehouse, but this system is designed for transactional workload, which is 100% OLTP system. So we split our storage layer into two levels. One is the shared cached layer, storage cache layer using local disk. And also the shared storage pool leverage the blob storage on the cloud, which is S3 on AWS. So with the help of this architecture, we can easily achieve the near unlimited scalability with confidence. Because with the help of S3, we can easily scale to petabytes level with confidence, because all the heavy lifting is already done by S3. It is so mature. Millions of people are using that. It is kind of like a de facto standard for blob storage. And you can see with the help of the shared storage, the other component of the database system have become near stateless. That means this architecture, we can actually leverage the elastic computing resource published by the cloud, just like the data warehouse did. So that makes the scale out and the scaling incredibly easy. So the benefits is not only the speed of scaling, but also the that brings the cost reduction coming from this architecture. Because you can see it is a tiered storage. The cold data will naturally stored in the shared storage, and the hot data will stored in the local cache. So that means we can leverage the low-cost storage for the cold data. So a couple days ago, I asked myself, can I reproduce the Flipkart's benchmark, the 1 million QPS one, in our new architecture? But I don't want to pay too much, right? And I don't have a lot of time to, setting up the environment. I just want to, do that. Okay, demo time. So I just simply launched the several benchmark client and keep increasing the workload. See what's going on. So basically, I just launched a sysbench client and keep increasing the workload, and the system will is actually scale out from 0 to 1.3 million within 20 minutes. And on the other hand, at the peak time, when it achieved the peak 1.3 million QPS, I just simply shut down the benchmark client, and the system automatically scaling back to 0 to save cost within a quarter. So the total time is just like within all this demo, I just finished within 30 minutes. And what's more amazing thing is I have achieved all of this without any special configuration or like the special tuning on the database side. Yeah, so that's really easy. Okay. So that's really cool, but I think there is still something we can do more, right? Let's put one step further. And with the idea of the separation, I think we, in the previous architecture, by separating the storage layer, we can, have a really amazing outcome. But we can, actually separate more. Let's take our focus to the computation. For example, I would say not all computation are equal. Just like in the database world, we always have some workload like point lookup, single row retrieval, or small OLTP transaction. This kind of workload is totally different from some complicated data aggregation, full table scan, the large data injection, and of course the online DDL. Sometimes you want to build the index on the large table, create an index for a specific column for large table. This different kind of computation requires different kind of like computing resource. So, but in the original architecture of the TiDB, everything every computation mixed together is like a mess, right? Like this crowd of Lego. So I'm thinking maybe we can separate the compute and compute, different kind of compute aside, right? Because the OLTP workload or the lightweight compute always require the computing resource 24/7 alive. But some heavy computation like the table scan, the DDL, it's not, you don't need to preserve the data all the time. So by applying the separation on the computing layer, so we can even better leverage the elasticity from the offered by published cloud. So this new architecture is still under development, but the outcome is quite amazing. So you can see this is the original architecture of TiDB serverless. Shared storage, the storage cache, and the computing layer, the SQL layer here. After the compute and compute separation, we actually split the heavy and the offline compute logic to several isolated microservices. And this microservices is running on the shared resource pool. So that means we can leverage the the elastic computing power from the cloud. So just like I said, this architecture is still under development. It will come to GA soon, but here is a preview demo for this architectural change. This demo is online DDL. I'm trying to add an index on the large table. As you can see, the new architecture with the cloud compute and compute separation architecture can easily achieve 10 times speed up compared to the original architecture. So that is amazing. I'm super looking forward that this technology applied in our product. So today I will make a bold guess, and it's my 2 cents. This architecture will be the new standard of database architecture, especially for the transactional workload on the cloud. So this is the just like the modern data warehouse did, using this cloud-native architecture, to make the multi-billion market. I believe that this architecture will become the cloud-native database de facto standard in the future. So, can we just stop here, or is there anything more we can do? The answer is yes. Yes, let's one step further. So, what would be the next challenge? I think when we have a scalable database, we have a super, large, huge cluster. I think the next challenge or the bottleneck will be ourselves, will be human being. I believe some of you here today maintaining a large-scale system. You may think, hey, maintaining a large-scale system is not that easy. Sometimes it's just beyond what human beings can do. For example, we provide database service to our customer. I would say 90% of the in production issue comes from the wrong index usage. For example, you wrongly choose the index, or you didn't build any index on your table, something like that. So we always want to recommend our customer using the right index in their for their workload. Today we offer this service by our amazing service team manually. But when you have thousands, even hundreds of thousands of customers, you cannot recommend the index to this customer one by one. Or maybe today we have several different database technology in the market. It is a super crowded market. So application developers sometimes juggling in migrating one database to another is super painful. For example, TiDB speaks MySQL protocol, but some users just want to just use Postgres. They want to use TiDB. That means they have to do the manually migration. So this is really hard. Or maybe we can offer some service like, hey, customer, you can, tomorrow you will have a traffic peak. Please prepare for that. That would be nice, right? So all of these fancy features today we offered, by human being. But At a large scale database, I think we cannot do that. It's simply not scale. But the AI can help here. So I would say today, everything related to generative AI is still in the very early stage. I'm not saying it is mature enough to apply in the, production. But last couple months, we have some interesting try. And the outcome is also really amazing and really promising. So just, I will share some examples with what we did a couple months within, this month. For example, just like I said, the index recommendation. So we built a small tool called Index Advisor for TiDB. So the idea is quite simple. This small tool just collects the optimizer metrics for your database and simply send it to generative AI, asking the question, hey, what do you think about this table? What's your recommendation for index? And the AI will just simply give you the answer, the decision. And then we send this decision back to the optimizer to verify is it actually working. So the outcome is amazing. It's a pretty simple idea, but the outcome is amazing. We apply this, we are using this tool to tune one of our internal benchmark. We call it Web3 benchmark. It is our internal benchmark for the OLTP traffic. So with the help of this tool, you can see the significantly improvement. The AI actually found some better index combination so that we can get the better performance on this benchmark without any manual human being knowledge. Another great example is the migration assistant. For example, like just like I said, the migrating the database from one to another is sometimes is a hard job. So we create a small tool. It's a little helper using generative AI to help users and application developer rewrite their application code. Here example is we have my application using MySQL, but a lot of queries includes the store procedure. And this great tool is just simply translate the SQL procedure to valid the TiDB query. Yeah, automatically. Yeah. Well, yes, with all those steps, a lot of innovation, a lot of optimization on the product side, I believe that our dream could come true. We want to provide a free and scalable database to every developer all over the world to help them to build amazing application to help people. So here comes one of my favorite use case, AJU. It is a NGO organization in Japan. This organization, they dedicate to help to improve the daily life for people with disabilities. So AJU is, it's NGO. They don't have a dedicated R&D team. They don't have a lot of engineers. What they really need is easy to use and reliable technology to build their application to connect people with needs. So they choose TiDB. They use TiDB service to build their application. So, and this is something I'm really proud of. Actually, helping people by our technology. That reminds me why we started this project, why we started this company. Yeah, they're using TiDB serverless, and you can try it today. So, yeah, that's all the technical talking. So I just mentioned the AJU case. I really appreciate they put their trust in TiDB. And that reminds me 8 years ago, we started this company. We just 3 engineers want to build a better database. But we believe that if you want to build a successful business in database area, you need to earn the trust from your customer and your trust from the community. So we started from the open source world. Every line of code, every design doc, we open source that. And I think that's we believe that the transparency will be the key to earn trust from our user. And 8 years later, today, PingCAP is an 8 years old company. We have now we have the enterprise product. We have the top-notch service team to offer the service of our technology, and most importantly, we have a lot of enterprise customer, our lovely customers, putting their most mission critical data on our technology. That's a great trust. In return, the investment in the security or the compliance of our database have never ceased. So I think that also contribute a lot to the foundation of the trust. So today, today I'm really happy to have one of our key partners on this stage to share their experience with us to build the trust to our customers. So I'm really looking forward for that. Thank you very much. Thank you for coming. We all the audience, we have like a small gift. It's a book with the signing. Yeah, this all of my talk. Thank you for coming. Thank you.